So today we are going to discuss basically about these two topics. The first one is pressure versus depth graph. Now this is regarding the last lecture where we developed an expression how to find the pressure at a point in a liquid, right? So we saw that P is equal to H rho Z. P was equal to H rho Z. Now, from here, we got P is proportional to H. The H is not height, it is the depth from the free surface of water at how much depth we are, that is H. So as the depth increases, the pressure also increases, and the relation is directly proportional. That means if one gets double, the other one also will get double. So in such relationship, if we represent it through graph, it will be a straight line that will pass through the origin. Must remember this one, okay? If the depth is zero means, let us say this is the free surface of water, and whatever the point we are selecting, we are finding out the depth from this free surface, right? Now, what if the point is on the free surface? Then what will happen? The depth is zero because we didn't go into the water. So that is why in that case, no pressure will be felt because above that there is no liquid. Okay, whenever we are finding out the pressure here, we are considering that there is a certain amount of liquid and due to that some pressure is being created on that point. But if you take into consideration the point on the surface, above that there is no liquid. Okay, above that there is no liquid, so there is no question of pressure. The pressure that will exist here is atmospheric pressure. Now that is a different topic we will study later, inshallah. But there will be no pressure of liquid because above this one there is no liquid to exert a pressure on this point. So when the depth is zero, the pressure is also zero, and that is why the line will pass through the origin. Depth zero, pressure also comes down to zero. As the depth increases, the pressure also goes up. So this is the graph, okay, in pressure versus depth uh, relationship. Okay. The next topic that we are going to discuss in details is buoyancy. Okay, so I will write the definition on the board first, then I will explain, inshallah. So here we have the definition of buoyancy. Okay, the upward resultant force. Now, what do we mean by resultant force? So let us say I have a body here. The force that I'm exerting in this direction is 10 Newton, and another force I'm exerting in this direction is 7 Newton. Can anybody tell me what will be the resultant force? Resultant force is the summation of all the forces that is acting on the body. Summation of all the force. Okay. So in that sense, someone of you might tell me that the resultant force is equal to, for this case, it will be 17 Newton, right? But it is not 17 Newton. Whenever we are considering force, we must take into consideration the direction also because force is a vector quantity. So in that case, what will happen? Let us say F1 is this 10 Newton plus F2, as it is in the opposite direction, it will be minus 7 Newton. So 10 minus 7, it gives us 3 Newton. This is our resultant force. Okay. So this is the resultant force. Whatever the force is acting on this one, you take the summation. You have to take the vector sum. Actually, if I put it into correct words, it will be the summation of all the vector sum of all the forces that is acting on the body. Vector sum bolte ki bujhay? You will take into consideration the direction. If you do not take into consideration the direction, then the summation of the forces is going to be actually 17 Newton. But when we consider the direction, that time we have to mention it is the vector sum because direction is important for vector. Okay, so I hope this is clear. Then, okay, so this is the upward resultant force. Why I mentioned upward? Because buoyancy acts in the upward direction. Okay, we will see. Why it is upward? Why it cannot be downward? We will see in a moment, no problem. So the upward resultant force acting on a body when it is fully or partially submerged in a fluid. Okay, so at first let me clarify this term fluid. Why I didn't say liquid? Why I didn't say liquid? Because fluid is a much broader term. fluid includes both liquid and gas. Always remember this one. Fluid is something that can flow. So liquid can flow, also the gas can flow. Air is a gas, right? And air can flow from one place to another, so it is also a fluid. So whenever you are confused that whether the substance that I have here is fluid or not, ask yourself a question whether it can flow or not. If it can flow, it is a fluid. If it cannot flow, it is not a fluid. If we think about solid substance, you will see that solid substance cannot flow on its own, right? You have to push it. Okay, without pushing, it will not flow from one place to another. So solid substances are not included in fluid. Only the liquid and gas, they can flow from one place to another. Okay, so that is why they are called fluid. So whenever we submerge মানে বাংলাটা হচ্ছে ডুবানো। ওকে, বাংলাটা বললে আমার মনে হয় তোমরা বেটার বুঝবা। When it is fully or partially submerged, পুরো বডিটাই যখন আমরা ডুবাই দিব, that means fully submerged. When we আমরা মনে করো অর্ধেক ডুবাইছি but অর্ধেক ডুবাই নাই, still the some force will be acting on the body, so that is that time also buoyancy will act. Okay, so fully or partially submerged in a fluid is called buoyancy. So the upward resultant force, now we will be doing some calculation regarding this. But before that, I want to know, is there any confusion in this definition? I will explain why it is saying upward, why it cannot be downward ever. I will explain that later. Other than that, do you have any doubt regarding any of the terms like partially or fully submerged or fluid? You already are familiar with force and resultant force. What is resultant force? I already explained. So if anybody have any doubt, kindly raise your hand. Nobody?
Sir, I have.
Bolo?
I did not understand this one. কালকে এটা yes
একটা বডিকে পানির মধ্যে ডুবাইলে পানির থেকে উপরের দিকে একটা ফোর্স আসে, সেই ফোর্সটাই বুনছি, ওইটাকে জাস্ট একটু ডেফিনিশন আকারে লিখছি যে আপওয়ার্ড রেজাল্টেন্ট ফোর্স।
স্যার এটা কি এক্সামে ডেফিনিশন হিসেবে আসবে আমাদের কাছে?
অবশ্যই। তুমি কি আর পরীক্ষার খাতায় লিখতে পারবা যে ছোটবেলায় আমরা বল দিয়ে খেলতাম পুকুরে, ওখানে এভাবে উপরে উঠে যেত, ওইটা বুনছি? এভাবে লিখলে আসলে হয়তো পাবা মার্ক কিছু, বাট ফুল মার্কস পাবা না আর কি। তো এটার জন্য এটা লিখতে হবে। ওকে, so now depending on this figure we will be doing some calculation. Okay, so for that I have to actually erase the definition. So when I ask you that air is a fluid or not, you will say that yes, air is a fluid. Remember this one, because air can flow. Acha, now here if you see, whenever you submerge a body in a liquid, what will happen? The pressure will act from all direction. Correct or not? See, pressure will be exerted on the upper surface, on the side surface, on the lower bottom surface, and on this side surface. Correct or not? But if you notice, I have shown the pressure or the force exerted from the upper on the upper surface and the bottom surface. On the side surface I did not show. Can anybody tell me why I didn't show? Nobody? Okay, I will tell you. Because the force exerted on this surface is equal to the force exerted on that surface. They both actually balance each other. What is happening? Let me explain through another object. Let us say I have this object. I'm exerting a force 7 Newton here, 10 Newton here, and in the upper direction 5 Newton, in the bottom direction 5 Newton. So while considering the resultant force or while calculating the resultant force, you will see that I can omit actually these 5 Newton because they are balancing each other. So as a result, they will not have any effect ultimately on this body. So the forces that I'm going to consider is only 10 Newton and 7 Newton. Okay. When I will calculate the resultant force, I will consider these two only. These two forces will not actually have any effect. So similarly it goes. Okay, on the force surfaces the force is acting, but this the force on this surface is equal to the force exerted on this surface. So as a result, they balance each other, and when they balance each other, we do not take them into consideration. But here, the pressure from the upper surface will not be equal to the pressure from the bottom surface. Okay, that is why now we will calculate the resultant force considering the upper force and bottom force only. Okay, now how to calculate this? At this surface, if I ask you what is the pressure at this surface, you can see that the upper surface is at h1 depth, and let us consider the area of this one A, and the bottom one also will have the same area. Let us say this is a uniform cross-sectional area substance. So what will happen? The area of this one we have considered A. The due to the uniformity, the bottom surface area will also be A. Acha. Now the top surface is at h1 depth. So the pressure exerted on this one will be h1 rho z. Okay, and let us consider this one as pressure 1 and pressure 2. That is the pressure on the bottom surface. The bottom surface is at the depth h2, right? So here I can write h2 rho z. Now definitely you can see that h2 is greater than h1. h2 is greater than h1, right? So rho g same, but h2 is greater than h1. So definitely P2 will be greater than P1. That means the pressure on the bottom surface P2, it will definitely be greater than the pressure from the upper surface. So as the bottom pressure is higher, definitely the resultant force that we are going to get, it will be in the upward direction. আমি যদি বাংলা একটু বুঝাই বলি, এটা আমরা এখানে দুইটা ফোর্স দেখতেছি, একটা উপরের সারফেসে আর একটা নিচের সারফেসে। তো উপরের সারফেসে যে প্রেসারটা দিচ্ছে সেইটা থেকে নিচের সারফেসের প্রেসারটা বেশি। এটা অলওয়েজ বেশি হবে, কারণ নিচের সারফেসটা কি বেশি ডেপথে থাকে, তো এটার উপরে প্রেসার বেশি কাজ করবে। আমরা জানি যে ডেপথ যত বেশি হয় প্রেসার তত বেশি হয়। তো নিচের সারফেসটা যেহেতু বেশি ডেপথে থাকে, ডেফিনেটলি এটার উপরে প্রেসার বেশি কাজ করবে। তো নিচের থেকে যে প্রেসারটা দিচ্ছে ওটা যদি বেশি হয়, তাহলে রেজাল্টেন্ট যে ফোর্সটা তুমি পাবা সেটা ডেফিনেটলি ইট উইল বি ইন দ্য আপওয়ার্ড ডাইরেকশন, বিকজ নিচের থেকে প্রেসারটা বেশি। সো আই হোপ দিস ইজ ক্লিয়ার। Okay, so if you remember, we know that pressure is equal to force divided by area. So from here, if I want to calculate the force, I have to multiply pressure into area. So similarly, from P1 I want to find out F1. What will be F1? Pressure into area. For F1 it is P1 into A. Now what is the value of P1? H1 rho g. Okay, then F2, this will be P2A, and P2 we can put the value H2 rho z. Okay, now I told you that buoyancy is the upward resultant force. So what I can write? Is equal to upward resultant force. The force that is being exerted in the upward direction, let us consider, we have considered this one to be F2, and the force from the upper surface, this is F1. So the buoyancy will be F2 minus F1. To be honest, you know, it will be actually F1, F2 plus F1, but এই F1 টা মাইনাস হবে, বিকজ F2 এটা আমরা উপরের দিকে যদি পজিটিভ ধরি, তাহলে F1 টা কি হয়ে যাবে, অটোমেটিক্যালি এটা নেগেটিভ হবে, বিকজ ইট ইজ ইন দ্য অপোজিট ডাইরেকশন। সো প্লাস মাইনাস হয়ে দেন তোমরা লিখতে পারো F2 minus F1. Okay, now we will put the value over there. F2 is H2 rho z, H2 rho z minus F1 is H1 rho z. Okay, so from here if I take rho z common, then what will happen? H2 minus H1 into rho z. Now H2 minus H1, this is basically height of the cylinder or any object that you have submerged. Okay, this is a cylindrical object I have considered. It might be some other object also. So H2 minus H1, this is the whole H2. From here, if you subtract this H1, you will get only H, that is the height of the object. So H2 minus H1 I can replace by H rho z. Okay, so buoyancy is equal to H rho z. Anybody have any doubt till now? Oh, I have made a mistake. ওয়ানের ভ্যালু বসানোর পরে আমি এটা মাল্টিপ্লাই করতে ভুলে গেছি, এখানে একটা এ হবে। এ নাজমুল তুমি কিছু বলতেছিলা মনে হয়।
না স্যার কিছু না।
ওকে, এটা যে লিখতে ভুলে গেছি তোমরা কেউ আসলে এতক্ষণ আমাকে বলো নাই, কেন বলো নাই কি জানি। ওকে, যাই হোক, তো এখানে a into h, that is area into height, that is equal to the volume. So volume into rho g, right? Now volume into rho, this one can be replaced by m, mass. Why? Because density is equal to mass divided by volume. So from here I can write m is equal to rho into v. So it is rho v. So rho v or v rho, this can be replaced by mass m, m into g. Now mg is what? Mg is equal to weight. So equal to weight of the displaced liquid. Okay. So mg is weight of the displaced liquid. Now why it is weight of the displaced liquid? Why I am not saying that the weight of the object? Okay, because here you will see that the volume is the volume of the cylinder, but also I can consider this one as the volume of the displaced liquid. Why I can consider this? Because তুমি যখনই একটা অবজেক্টকে আসলে কোন একটা লিকুইড বা ফ্লুইডের মধ্যে সাবমার্জ করবা, তখন দেখা যাবে কি ও কিছু জায়গা দখল করে নেবে, তাই না? ও কতটুকু জায়গা দখল করবে? যতটুকু ওর ভলিউম, ঠিক ততটুকু জায়গায় ও দখল করবে। যেমন আমি তোমাকে একটা এক্সাম্পল দিয়ে যদি বলি, একটা গ্লাস মনে করো একদম ফুল, ঠিক আছে, এখানে তুমি মনে করো তোমার আঙ্গুল ডুবাইছো, ফিঙ্গার, তাহলে কিছু পরিমাণ ওয়াটার পড়ে যাবে না? তার মানে তোমার ফিঙ্গারটা ওয়াটারের মধ্যে গিয়ে কিছু জায়গা দখল করছে দেখে কিছু ওয়াটার বাইরে পড়ে যেতে হয়েছে, কিছু ওয়াটার সরে গিয়ে ডিসপ্লেস হয়ে গিয়ে তোমার ফিঙ্গারকে জায়গা করে দিতে হয়েছে। Understood my point? Okay. So this volume is the volume of the cylinder or the object, or we can say this is the volume of the displaced liquid. Okay, so this is the volume of the displaced liquid, and rho is what? The density of this liquid. So কোন একটা লিকুইডের ডেনসিটি আর কোন একটা লিকুইডের ভলিউম যদি আমরা মাল্টিপ্লাই করি, we will be getting the mass of that liquid. কোন লিকুইড, যতটুকু লিকুইড এখান থেকে ডিসপ্লেস হয়ে গেছে, তো ওইটার সাথে যদি আমরা acceleration due to gravity মাল্টিপ্লাই করি, we will be getting the weight of the displaced liquid. This is a very important calculation. Okay, buoyancy is equal to the weight of the displaced liquid. তার মানে কি, এই যে একটা বডিকে আমরা মনে করো কোন ফ্লুইডের মধ্যে সাবমার্জ করলাম, ও কি করবে, কিছু ফ্লুইডকে ডিসপ্লেস করে দিবে, ওই যে ফ্লুইডের যতটুকু ওয়েট না, সেটাই হবে এই যে বডিটার উপরে যে বুয়ান্সি কাজ করতেছে সেটার ইকুয়াল। This is very important. So if you have any doubt, please clear it now. Okay, today we are going to discuss only about this because this is very important. So if anybody have any doubt in any of the lines, please tell me right now. Raise your hand. Fatima,
না
Abdullah,
স্যার নেই।
Robin, Nahida. Nahida আজকে জয়েন করছে? No, Nahida নাই। Okay. বলো ফাতিমা, বলো, আনমিউট করে বলো, অসুবিধা নেই।
স্যার আপনি না বললেন রেশন করতে।
হ্যাঁ, তো ডাউট আছে? ডাউট না থাকলে হ্যান্ড রেজ কেন করবে শুধু শুধু? আচ্ছা ঠিক আছে, যাই হোক, তো তাহলে তোমরা বুঝতে পারছো আশা করি। এই ক্যালকুলেশনটা আসলে তোমাদের বইতে ক্লিয়ারলি লেখা নাই, ঠিক আছে? তো তাইলে এই ক্যালকুলেশনটা আগের যে বইটা ছিল না, ওইটাতে ক্লিয়ারলি লেখা আছে, তো ওখান থেকে আমি একটা পিকচার তোমাদেরকে দিয়ে দিব ইনশাল্লাহ। এই সেম ক্যালকুলেশনটা আসলে ওখানে দেখানো হয়েছে। তো এই জিনিসটা আজকে তোমরা একটু বাসায় ভালো মতো স্টাডি করো। আমি আজকে তোমাদেরকে আর বেশি কিছু পড়াবো না, তো এই জিনিসটা বাসায় একটু ভালো মতো দেখো এবং বোঝার চেষ্টা করো। আমি পরের দিন কিন্তু জিজ্ঞেস করবো যে হোয়াট ইজ বুয়ান্সি, বুয়ান্সি ইজ ইকুয়াল টু ওয়েট অফ দ্য ডিসপ্লেসড লিকুইড। এটা বোঝাটা খুবই ইম্পর্টেন্ট, বিকজ এটার উপরে আমরা অনেকগুলো ক্রিয়েটিভ সলভ করব, এবং সামনে আমরা আরেকটা জিনিস শিখবো যে একটা বডিকে যখন আমরা একটা ফ্লুইডে সাবমার্জ করব, এটা কি ফ্লোট করবে নাকি ডুবে যাবে। immersion and flotation of a body. Okay, it depends greatly on this buoyancy. So if you do not understand this buoyancy, definitely you are not going to understand anything that I'm going to discuss in the next class regarding the immersion and flotation of a body. Okay, so please, also before that we will study Archimedes law, and that is also entirely dependent on this buoyancy. So understanding the calculation of buoyancy is of, you know, great importance. So please revise this one before the next class, and if you come across any doubt, let me know. Okay. Okay, so today we end our class here. See you in the next class, inshallah. I request you again to go through this topic very properly. And if I forget to give you the picture from the previous book, please remind me through WhatsApp. Assalamu alaikum wa rahmatullah wa barakatuh.